Yes, so this is our circuit diagram for measuring the efficiency and regulation of a single phase transformer. This is the connection of single phase 230 volt supply which is connected to an auto transformer. Through auto transformer there is one ammeter connected. Through ammeter there is one wattmeter. So these both ammeter and wattmeter are going to measure primary current and primary power. Now from this here primary winding of the transformer is connected and which is coming back to your auto transformer. Here we have connected one voltmeter. Through multimeter we can measure this voltage. So this is the connection of your primary side. Now when we come to the secondary side, this is our secondary winding. Through secondary winding again one ammeter is connected. So this ammeter is going to measure the secondary current, and here the load is going to be connected. So we are going to connect single phase load in form of a load bank, which is our single phase power load bank where bulbs are connected. Resistive type of load is there. So if you see the practical implementation of this, so the circuit diagram we have connected here. This is your auto transformer which is getting 230 volt AC supply. Fine. From this we have connected one ammeter. The range of the ammeter was 0 to 5 ampere. So we have taken 5 or 10 ampere ammeter, AC ammeter. From ammeter next connected was your wattmeter. So this is your wattmeter. From wattmeter, if you see there are two coils in this wattmeter. The first coil point is connected from this ammeter, that is M point. The next point M and C point are short circuited. The next point is L point, which is having connection to the single phase transformer primary winding. This is your single phase transformer. These are your primary winding terminals and these are your secondary winding terminals. So wattmeter terminal is connected to this one terminal of your single phase transformer, and the second terminal of your single phase transformer is coming back to your auto transformer. So here it is coming back to your auto transformer. If you see in the circuit diagram, this winding of your wattmeter is also coming back to your auto transformer. So what we have done, we have connected this wire to wattmeter winding, and through this wattmeter we have connected this transformer winding. So all are shorted together. So this completes the circuit of your primary side. Now when we come to the secondary side, through secondary terminal winding, this is connected to your second ammeter. Ammeter terminal is connected to your load. If you see, this is your load bank, single phase load bank, and the second terminal of this load bank is connected to again the transformer secondary winding. Now here at secondary side we have taken only 50% of winding. That means whatever we are giving supply voltage at primary, half of that we will receive at secondary. That means this transformer will be working as a step down transformer. Now for voltage, we are going to measure voltage through this multimeter. So no need of connecting separate voltmeter. We can get the voltage through this multimeter. Now here this is your load bank, which you can see. Here we have connected the bulbs. That means we are connecting resistive type of load, and single phase load bank is this. So now we will perform our practical. What we have to do, we have to take the primary wattage reading and secondary wattage reading. Okay, so one by one we'll start. You have to make sure whenever you are opening or switching on this auto transformer, this should be at 0. If you do not do this, this transformer coil will get burst and you will get a blast here itself. The coil will get burnt. So you have to make sure every time before switching on that this should be at 0. Okay, so this is at 0. Now I'll switch on this. Now you can see here in the multimeter right now the voltage showing is just 6 volts. I'll start increasing the voltage and I'll make it to 230 volts. Single phase AC supply, you all know, is 230. So we are increasing the voltage. We are going to increase it till 230. So we have set it to 230 volts. Now for 230 volts, if you see, this ammeter is reading 0, this wattmeter, that means I primary is 0, W P, that is primary wattage, is also 0, the secondary current IS is also 0, and if you see the secondary voltage, is, if you see, 114.5, that is half of your 230 volts. Okay, now why we are getting this 0 value, this first reading? Because we have yet not switched on any loads. If you see, all the bulbs are off, so there is no load connected to your transformer. That's why all the meters are showing 0. So this first reading corresponds to your no load reading. Okay, now we are going to increase the load one by one. So I'll keep on switching this bulb and increase the load. So if you see now, the current you are getting is 1 ampere. You have to read the below line because you have connected to 5 ampere. Okay, the range here is 5 ampere. So you need to read below line. So the current IP is 5 ampere. If you see here wattage reading, so wattage reading is reading 150 and 300. So this will be 100 watts. Okay. So the reading here, if you see, is showing 100 watts. That I'll tell after. Now here, if you see, the primary voltage is 227.9. It reduces from 230. Why? Because we have switched on the load. So if you are going to increase the voltage, if you are going to increase the load, the drop in voltage can be seen. Now if you see secondary voltage, definitely it will be half of that. So you can see here the secondary voltage Vs is 111.5, and if you see here the secondary current, that is Is, the reading of that is 1.98 or 1.99. If you see here, you have to read the above scale because the range of the meter is 10. So above scale should be read. So it is 1.98 if you see. Okay, fine. Now again I'll increase the load. Previously, now see, the voltage has 227. So I have to again bring it to 230 and then I have to increase the load. Fine. Now I'll increase the load again. Fine. Now if you see, the current, when we have increased the load, the primary current has increased to 2 amperes. The wattmeter reading has reached to around 210 watts. The primary voltage, if you see, is 232. If you see the secondary voltage, it will be half of that, 111.4 or 5. And if you see secondary voltage, secondary current, it is around 3.5. okay, it is coming 3.5. fine. Now similarly again we will increase one load, and this is how we are going to keep on increasing the load, and according to the loads we are going to get your readings for primary voltage, primary current, secondary voltage and secondary current. Okay, So this is the procedure for getting the values of primary current, primary voltage, wattage and secondary current, secondary voltage. Okay, fine.